Hey everyone, welcome back to iTech Aspirant. In today's video, we're going to build something really exciting, a real-time, voice-powered AI chat application for Android using Kotlin and the powerful ZEGOCLOUD Conversational AI. By the end of this video, you'll have a real-time conversational AI on your phone. Don't skip any part, so you can avoid any issues and run it smoothly. It's easier than you think, and the result is amazing. So, before we write a single line of code, let's first check the demo of our AI agent.
Can cover threats, defenses, protocols, and more.
First, open your browser and search for ZEGOCLOUD. Click on the official link. On their website, go to the Solutions tab, and you'll see Conversational AI. Let's open that. Here, you can see its powerful use cases. And if you scroll down, you'll find links to demo apps, documentation, and the developer blog, which are all great resources to explore. Now, I'm going to log into my account. If you don't have one, just sign up, it's quick. After sign up, you get 10,000 free minutes to test everything out. I want to show you my own usage. Before I started this project, I had only used about 3 minutes. But after fully testing this AI agent, I've now used over 1,800 minutes. This means I've tested it in every way possible, and my conclusion is that it's an amazing and very helpful service. So don't skip any part of this tutorial, and you'll get it running smoothly. Okay, let's get started. First, click on Create Your Project. For the project type, select Voice and Video Call and click Next. Here, give your project a name. I'll call mine AI Agent. As we scroll down, we see two options: start with UI kits or start with SDK. You can select your environment here, like Android, iOS, web, and even Flutter. For this tutorial, I'll start with UI kits because it makes the initial setup very clear and easy to understand. Now that the project is created, we select our framework. I'll go with Android. Here, you can select your preferences, then click Save and start to integrate. And ZEGOCLOUD has set up our project and given us an app ID, an app sign, and server secret. This is super important. These are our secret keys. Copy them somewhere safe, and don't share them publicly. Now, let's click on Quick Start. In the product list on the left, select AI Agent. And for the platform, choose Android. The guide is in Java, but don't worry, we'll be converting it to clean Kotlin. Next, click on Quick Start Voice Call. Let's first turn this to dark mode. Much better. Now, scroll down and here you see the step-by-step diagram of our project. Next, click on Integrate the SDK. Scroll down and here I'm going to use Automatic Integration Maven. You'll see this Maven line. Now, let's head over to Android Studio and create a new project. Select Empty Views Activity and give your app a name. Make sure the language is Kotlin and click Finish. First, let's create our app's layout file. The main container will be a constraint layout, which gives us a flexible way to position all our elements. We need constraint layout dependency for our user interface. Open your build.gradle.kt file and paste it in. Now copy the Maven line from the ZEGOCLOUD page, open the settings.gradle.kt file and paste it here. We just need to convert it to the new Gradle style. Perfect. Now, back to the ZEGOCLOUD guide and copy the dependency line. Check the latest version from the release notes. Now open your build.gradle.kts file and paste it in. Let's replace XYZ with the latest version and update the syntax for Kotlin Gradle. We need to add required permissions. Back in the Quick Start guide, copy the 3 permission lines. While we're here, we'll also need the OKHTTP3 dependency for networking with our server later. Now click Sync Now to download and add these libraries to our project. With our dependencies sync, we need to add required permissions. Go to your Android manifest.xml file and paste these permissions used above the application tag. Finally, let's design our app's layout. Open activity main.xml. I'll design our layout quickly, since these are really simple and straightforward steps. At the top, we have a simple text view that acts as a header, displaying AI Assistant. The middle section is a scroll view which contains a linear layout. This is the most important part. Our chat messages will be dynamically added here, and the scroll view will let us scroll through the conversation. At the bottom, we have another linear layout. This holds our controls. Now a text view with the ID status text to show the connection status, like connecting or listening. Now create an image button called Start Call button. Set its visibility to gone, so it's hidden when the app starts. Now just copy this and paste for another image button called Stop Call button. It's visible by default. We will write Kotlin code to toggle these buttons later. Alright, with our layout and dependencies ready, it's time to bring our app to life. Let's open up MainActivity and start writing the core logic. We can remove the default code inside on create for now. We also need to change our class to inherit from app.kt activity. This is a crucial step that gives us access to modern Android features and ensures compatibility. Add these dependencies. Now, let's link our XML layout to this activity, right at the top of onCreate. Pass it our layout file, which is activity main. At the top of our class, we need to declare a few properties that our activity will use. First up is the request permission launcher. This is the modern and correct way in Android to ask the user for permissions, like for the microphone. Next, let's define some constants for our user and the chat room. This keeps our code clean and makes it easy to change these values later. First, a user ID. This needs to be unique for every person using the app. For our tutorial, we'll just generate a random number. Then we'll add a username and a room ID for our chat session. And a stream ID, which is a unique ID for our audio stream. Great, now, let's go inside onCreate and connect our buttons. We'll get a reference to our stop button from the layout. And set a click listener on it. When this button is clicked, it will call our stop call function. We haven't created this function yet, so it will be red. We'll just comment it out for now and come back to it later. We'll do the exact same thing for our start button, which will call a restart call function. Perfect. Now for the permission logic, let's create a new function called setUpPermissionLauncher. As the ZEGOCLOUD guide recommends, this is where we'll initialize the launcher we declared earlier. We use register for activity result and pass it request permission. This tells Android we're asking for a single permission. The second part is a callback, which is the code that runs after the user makes a choice. Inside this callback, we get a boolean called isGranted. If it's true, we'll call a function to start our ZEGOCLOUD process. If it's false, we'll handle the denial. We'll create those functions later. Let's fix this activity result launcher. This is the modern Android component for handling results, like a permission request. Just click on it and import the class. Now let's scroll down to our setup permission launcher function. It looks like I have a small typo here. Alright, let's add the rest of our permission logic. We need a function that checks if we already have permission before we even ask for it. So, right above Setup Permission Launcher, let's create a new private function, check for audio permission. Inside this function, we'll use context compat.check self permission to see if the record audio permission has been granted. If it's not granted, then we'll call request permission launcher.launch to show the pop-up to the user. We've got some new red text. First, let's import manifest. Be sure to select the android.manifest import. We don't need that, so let's delete it from our import list at the top. We only want android.manifest. Next, let's create a function to handle what happens when the user denies the permission. We'll call it handle permission denial. Inside this function, we need to check if the user permanently denied the permission by checking don't ask again. We do that by calling should-show-request permission rationale. If this is false, it means we can't ask them again, so we'll show a dialog. We'll create that function in a moment. If it's true, it means the user just pressed deny this one time. In that case, we'll just show a simple toast message telling them the permission is required. Great, now we can wire this up. Let's go back to our setup permission launcher function and uncomment the handle permission denial call. The new show permission denied permanently dialog function is red, which is fine. We'll just comment that one line out for now, since we haven't created it yet. I'm breaking all this logic into small, clean functions so it's really easy to read, and so you can easily find and change any part you want later on. Now let's create our main success function, the one that runs when all the permissions are good to go. Start Zego process. Okay, what's the first thing we do when we have permission? We'll show a toast to the user. I'll just find the toast message I wrote earlier and paste it inside Start Zego process. I'll change the message to permission granted. After showing the toast, this function will be our main control center. It will be responsible for three things. First, initializing the ZEGOCLOUD engine. Second, setting up all the event handlers to listen for messages from the AI. And third, fetching our token from the server and logging into the chat room. Let's create the first one, init.Zego engine. This function will set up the ZEGOCLOUD engine with our app ID and scenario. Alright, inside it, we first create a Zego engine profile. This is an object that holds our configuration. We'll use the apply function to set its properties. Inside here, we set 3 properties. First, the app ID, which we'll get from a constant file in a second. Second, the scenario. This is important. We'll set it to Zego Scenario High Quality Chat Room. This tells ZEGOCLOUD to optimize for voice, and as the guide says, it avoids the app asking for camera permission, which we don't need. And third, we pass the application context, which we get by writing this at MainActivity. Finally, with our profile complete, we just call Zego Express Engine.create engine and pass it our new profile. And that's it, our engine is initialized. Now, I'm going to quickly go to my ZEGOCLOUD project configuration and copy my app ID. Make sure you never share your app ID or server secret with anyone. You'll notice constant.appid is red. We need to create that file. This is the best way to keep your secret keys out of your main code. Inside constant.kt, we'll create an object and declare our app ID as a const val. Great, now, let's go back to MainActivity.kt. You'll see the error is gone now. Now for the most important function, log into room. We'll create this right below our init_Zego engine function. It takes one parameter, the token we just fetched from our server. Let's update our UI to tell the user what's happening. We'll find our status text by its ID. It looks like I forgot to give my text view an ID in the XML file. That's an easy fix. And set the text to logging in. Much better. Now, to make our code cleaner, we're going to store the room ID in a class-level variable. This way, all our other functions can access it easily. And this is a critical step for good audio. We need to apply all the best practice audio settings before we log in. We'll create a new helper function for this called configure Zego engine. Let's quickly create the empty function down below just to make the error go away. We'll fill it in right after this. Let's also declare the other variables we'll need to manage our session state, current agent ID and current room ID. Okay, back in login to room. We need to create a Zego room config object. This tells ZEGOCLOUD how to join the room. And now, the main event, Zego Express Engine.get engine.login room. We pass it our room ID, a new Zego user object with our user ID and username, and the room config we just made. This function has a callback that tells us if the login was a success or a failure. The callback gives us an error code. Because we're going to update the UI, we must wrap our logic in run on UI thread. Inside, we check if the error code is 0. A 0 means success. If it's successful, we'll update our status text. Then, we immediately call start publishing stream to send our microphone audio. And mute microphone false to make sure our mic is on. If the error code is not 0, we'll just show a failure message on the screen so we know what went wrong. Now that we're done logging in, let's go fill in that configure Zego engine function. This is based on the ZEGOCLOUD guide for best practices, and it's what makes the audio sound so clear. First, we get the engine. Then, we enable all the audio enhancements. Enable EC is for echo cancellation. Then AGC is for automatic gain control. And A and S is for noise suppression. We'll set the modes to A balanced and medium as the guide recommends. Next, we'll create an advanced Zego engine config to handle volume ducking and adaptation. This helps make the conversation sound more natural when both you and the AI might be speaking. Now for the most important part of our app, the set Zego event handler. This function is the ears of our activity, listening for all the events from the ZEGOCLOUD servers. Inside, we get the engine and call set event handler. Creating a new anonymous object that inherits from my Zego event handler. The first event we'll override is on publisher state update. This fires when our own audio stream status changes. We'll check if the state is publishing and the error code is 0. This tells us our microphone is successfully live. As soon as we're publishing, this is the perfect time to tell our server to start the AI agent. To do that, we'll need a new Kotlin file called ServerAPI. Let's create that really quickly. We'll pass in our room, user, and stream IDs. This function will have its own callback. Let's start with onSuccess. This function will be called by our server API file if the server successfully creates the AI agent. It also gives us the agent instance ID. Let's update our UI. We'll use run on UI thread to find our status text and update its text to AI agent is connecting. Now we have to handle the onFailure function. This will be called if our server failed to create the agent, maybe our Node.js server is offline, or there was some other error. Inside here, we'll also use run on UI thread to update the status text. We'll set the text to start call failed. Next event is on room stream update. This fires when anyone else joins the room, which in our case will be the AI agent. We check if the update type is add. Then we loop through the new streams. And check if the user ID starts with agent. If it does, we know it's our AI, and we call start playing stream to begin listening to it. Next, let's add on player state update. This gives us feedback on the AI's audio stream. If it's playing correctly, we'll update our status text to listening. If there's an error, we'll display that. And finally, the most powerful and important event, on Rec Experimental API. This is the advanced listener that receives the transcribed text data from both our speech and the AI's replies. This code looks a little complex, but it's very efficient. We use run catching to safely parse the JSON. The server sends us a message that actually contains another JSON string inside it, so we have to parse it twice. Once we have the inner data, we get the data object and check the end flag. The most important part is the CMD field. If CMD is 3, that's our speech. We'll grab the text from the message, check if it's a user message, and then send both the text and who send it to add message to chat view function, which will handle creating the blue and gray chat bubbles. And we wrap it all in a on failure block to log any parsing errors, just in case. And our event handler is complete and ready to power our conversation. Alright, we have all our main functions planned out. Now it's time to build the helper function that actually creates our chat bubbles. This one is called add message to chat view. This function takes the message text and a boolean, his user message, which tells us if it's a blue user bubble or a gray AI bubble. First, we create a new text view. And to make the code cleaner, I'll use the .apply block. This lets us set all the text view's properties in one place. We'll set the text to our message, the text size to 16, and the text color to white. Next, we'll set the background. We'll use an if statement. If his user message is true, we set the background to our message background user drawable. Otherwise, we set it to message background AI. Now, for this to work, we need to create those two drawable files. Let's go to our race drawable folder. I'll call the first one message background user. I'm just pasting in some simple XML for a shape. As you can see, it's a rectangle with a blue color, some padding, and rounded corners. Notice the bottom right radius is smaller, which gives it that classic chat bubble look. Now, let's create the second one, message background AI. I'll paste in the code for the AI gray bubble. It's almost identical, just with the gray color and the bottom left radius is the smaller one this time. Great! Back in MainActivity.kt, our set background resource line will work perfectly. We create new linear layout.layout params and inside its own apply block, we'll set the gravity. The last thing we need to set in this apply block is the layout params. This is really important for making it look like a real chat app. We'll use an if statement to set it to gravity and for the user and gravity start for the AI. This aligns the bubbles to the right and left. We'll also add some top and bottom margins. And here's a neat trick. We'll set the margin start and margin end based on who is speaking. This creates that offset look, just like in a real messaging app. You'll see this .dp2px function is red. And let's quickly create that dp2px helper function we used. This is a little extension function on int that converts a device-independent pixel dp value to raw pixels, which is what the layout params need. Now that our message view is fully configured, we'll add it to our chat container. It looks like chat container is red. I forgot to add the ID to the XML. Let's quickly jump to activity main XML. And the final step in this function, to make sure the chat window always shows the newest message, we'll get our scroll view and call scrollView.post. Inside, we call full scroll view, focus down. This tells the scroll view to automatically scroll to the bottom every time a new message is added. Alright, our app is getting pretty complex. To make our code cleaner, we're going to create some helper functions to manage the UI state of our start and stop buttons. I'll add them right above our add message to chat view function. First, update UI for call state. This function takes a boolean, is call active. Based on this, it will show or hide the correct button using view.visible or view.gone, and it will also update our status text. Next, we'll create our restart call function. This one is simple. It clears all the messages from the chat container, calls our new UI function to show the stop button. and then kicks off the start Zego process again to make a new call. And now we can write our stop call function, which will be called when we press the red hang up button. First, we safely get the current agent ID. If it's null, we just return because there's no call to stop. Next, as per the ZEGOCLOUD guide, we need to notify our server to delete the agent instance. We'll create a JSON object with the agent instance ID and room ID, and convert it to a request body. Now we build the request. Make sure to add your server's stop call URL here. I'll just leave it blank for now. And finally, we use OKHTTP client to send the request. In the onFailure callback, we just log an error. In the onResponse callback, if the server's response is successful, we do two things: log out room to leave the chat, and we set current agent ID back to null. And the very last step is to update our UI. We must use run on UI thread. And we'll show a call ended toast. And then call our update UI for call state false function. This will automatically hide the red button and show the green start button again. We've built all our functions. Let's do a final cleanup in onCreate. I'll uncomment the stop call and restart call functions inside our button listeners. And at the end of onCreate, we need to add the two functions that actually start everything: set up permission launcher and check for audio permission. One last step. We need to override the onDestroy function. This function is called when the user fully closes the app. Inside here, we must call stop call to end the session on the server, and Zego express engine.destroy engine null to release all the ZEGOCLOUD resources. This prevents memory leaks and saves your service minutes. And don't forget super.onDestroy at the end. Our main activity is officially complete. Let's move to our final Kotlin file, ServerAPI.kt. First, we'll change this from a class to an object. This makes it a singleton, so we can call its methods from anywhere without creating an instance. Inside our ServerAPI object, the first thing we'll do is create an interface called callback. It will have two simple functions: on success, which will give us the agent's ID, and on failure, which will tell us if anything went wrong. We're going to create the main function, notify server, to start call. This is the bridge that connects our Android app directly to our Node.js server. His function takes in our room ID, user ID, stream ID, and, of course, the callback object we just defined so it can report back to the main activity. First, we create our OKHTTP client. This is the worker from the OKHTTP library that will actually make the network call for us. Then, we define the URL we want to talk to. This part is critical. This IP address must be the IP of your computer running the Node.js server. Your phone and your computer must be on the same Wi-Fi network for this to work. Next, we need to package up the data to send. We'll create a simple JSON string using Kotlin's multi-line string feature. We're just passing the room ID, user ID, and stream ID. We turn that string into a proper request body, telling OKHTTP that it's JSON. And then we build our final request object. This is a post request, and we're sending our JSON body to the URL. Now for the most important part. We call client new call request, enqueue. The enqueue command is key. It tells OKHTTP to run this network call on a background thread, which is essential so we don't freeze our app's user interface. Inside enqueue, we get two functions we need to override. The first is on failure. This is called if we can't connect at all. Maybe the server is offline or the Wi-Fi is down. And you'll notice I'm using OKHTTP callback and OKHTTP call. That's because of the import aliases we added at the top of the file, which prevents a name conflict with our own callback interface. It's a great little trick. In here, we'll log the error to our logcat. And most importantly, we'll use our callback, CB, on failure, to send the error message back to main activity so it can update the UI. The second function is onResponse. This is our success path, which runs when the server answers us. We'll use response.use, which is a handy Kotlin function that automatically closes the response for us to prevent memory leaks. Inside, we get the response body as a string. Then we check if the response was successful and if the body isn't empty. If it is, we use a try block to safely parse the JSON text. We're looking for one specific thing, the agent instance ID that our server sends back. If we find it, we send it back to main activity by calling our onSuccess callback. And finally, if the JSON parsing fails, we'll catch the exception and call on failure. We'll also call on failure if the server response itself was an error, like a 400 or 500. Alright, our entire Android application is now complete. It's ready to talk, but it has no one to talk to. Now, we have to build the second half of our project, the Node.js server. This will be the brain of our AI. Go to your browser and type in Node.js. You'll want to go to the first official website. Most of you probably don't have Node.js installed, so we'll do that first. If you already have it, you can skip this part. Can click on Get Node.js. Here you can select the version of Node.js and for your specific operating system, like Windows or macOS. Click on Windows Installer. Once the download is finished, open your Downloads folder. You'll see the installer right here. Let's double-click to run it. The setup wizard is very straightforward. Click Next. Read and accept the license agreement, and click Next. Here, you can select your location. I'm just going to leave it as the default. Click Next. Check this box to automatically install the necessary tools. This will make sure you have everything you need for native modules. Click Next. And finally, click Install. This will take a minute or two to install. Once it's done, it will automatically open a PowerShell window to install those extra tools. You can just minimize that for now. Let's verify that Node.js is installed correctly. Open a fresh command prompt. Now, type node v and press Enter. If you see a version number, it means Node.js is correctly installed. Now, type in pmv and press Enter. Our main activity is almost complete, but I've spotted a few typos we need to fix before we move on. This is a normal part of coding, so let's hunt them down. Let's fix these to use the correct class properties. I've typed it with a lowercase f. This needs to be uppercase F to correctly override the interface. Our Android code is now almost complete and ready to talk to our server. So, let's build the server. You can select Server from the menu. You'll see the basic API structure here, like the register agent function. This is what we're going to build. Now, I'm also using a ZEGOCLOUD blog post that has a great walkthrough. I've provided the link for that in the description as well. Let's scroll down, and here it is. It shows us exactly how to create our project folders. So, I'm going to open my command prompt, and I'll just paste those commands right in. First, mkdir AI voice agent to create our main project folder. Then cd AI voice agent to move into it. Then mkdir server to create our server folder. And cd server to go into that. Now that we're in our server folder, we need to initialize our Node.js project. We do that by running npm init.y. The y flag just automatically says yes to all the default questions. Great, that command created a Package.json file, which is like the settings file for our server. Let's open our server folder and edit this file. I'm using an editor called Brackets, but you can use VS Code or even just Notepad. Okay, let's make a few changes. First, I'll change the name from server to Zego AI Agent server. Next, and this is very important, we have to add a new line, type module. This tells Node.js to use the modern import syntax. Now, under scripts, I'm going to remove this default test line. Instead, I'll add a start script that just runs node index.js. And a dev script that uses nodemin index.js. Nodemin is a great tool that automatically restarts your server when you save the file. I'm just going to remove the last 3 lines and paste in our dependencies here. This tells npm which libraries we need, Axios for making network requests. .env for our secret keys. And express for the server itself. We'll also add dev dependencies for nodemin. Now, let's go back to that blog post. The next step is to create our .env file. This is a very important file that will hold our secret keys. Let's create a new file. I'm just going to paste the lines from the ZEGOCLOUD blog right here. Now, For this tutorial, we aren't going to use a dash scope API key, so I'll remove that line. Instead, I'll add a line for our server URL. And now, we need our app ID and server secret. Let's go to our ZEGOCLOUD project configuration. I'll copy my app ID and paste it in here. And now I'll copy my server secret and paste that in. Make sure you never share these keys with anyone. Now let's save this. We must save it in our server folder. And the name has to be exactly .env. We need to create is our token helper.js. This is a critical helper file that contains the official ZEGOCLOUD logic for securely generating version for tokens. This code is a direct JavaScript translation of their official TypeScript example. This file will be responsible for one thing: generating the secure, encrypted token that ZEGOCLOUD requires. Let's start by importing the one tool we need from Node.js's built-in crypto library. Now, we need a few helper functions. The first one will be called makeNonce. Nonce is just a random number used once in cryptography to prevent attacks. It's a simple function. Inside, we'll create a new buffer that's 4 bytes long. Then, we'll write a random 32-bit integer to it. This math.random formula just generates a number within that range. And finally, we'll read that number back and return it. Next, we need another helper to create a random IV, or initialization vector. This is just another piece of random data to make our encryption secure. We'll define a string with all the lowercase letters and numbers we can use. Then we'll create an empty result string. Now, we'll loop 16 times. Each time, we'll get a random character from our string and add it to our result string. After the loop, we just return the 16-character random string. Our next helper needs to figure out which encryption algorithm to use. ZEGOCLOUD's server secret is 32 bytes, but we'll build this getAlgorithm function to support other sizes just in case. It takes the key as an argument. We'll use a switch statement on the key.length. If the key is 16 bytes, we return AES 128 CBC. If it's 24, we return AES 192 CBC. And if it's 32, we return AES 256 CBC. And if the key is the wrong size, we'll just throw an error. Okay, now we can build the function that actually does the encryption. We'll call it AES encrypt. It will take our plain text, the key, and the IV. Inside, we'll create our cipher using the create cipher if we imported, and we'll pass it our get algorithm function, the key, and the IV. We'll set auto padding to true, then we'll update the cipher with our plain text. Then, we call cipher.final to get the last encrypted block. And finally, we'll buffer.concat the pieces together and return the result. We've built all our helper tools. Now we can build the main function that our index.js file will actually call. We'll export it so other files can use it. Export function generate token 04. It will take 5 arguments, our app ID, the user ID, our secret, the effective time in seconds, and a payload. First, let's add some validation. This is just good practice. We'll check that app ID is a number. We'll check that user ID is a string. We'll check that stream ID is a string and it is exactly 32 bytes long. And that effective time in seconds is a number. If any of these fail, we'll throw an error. Now let's build the token. First, we get the current time in seconds. Then, we create the token info object. This is the heart of our token. We'll add our app ID, the user ID, our nonce by calling makeNonce, the C time we just created, the expire time, which is just the current time plus the effective time, and finally, our payload. Now we need to encrypt this object. First, we'll turn it into a JSON string called plain text. We'll get our random IV by calling makeRandomIV. Next, we'll convert our string secret and IV into buffers, which is what the encryption function needs. We'll call them keyBuff and IVBuff. Now we can encrypt it. This is the final, technical part. ZEGOCLOUD requires the token to be in a very specific binary format. We'll create a new buffer that's the exact size of all our parts combined. Now we write all our pieces into this buffer in the correct order. And the very last step, we return the string 04, which stands for version 4, and then we add our packed buffer converted to a base 60 for string. Now this is correct not equal operator. The correct function name is right int here. Alright, with our token helper file saved, it's time to create the main file for our server. In our server folder, let's create a new file named index.js. Okay, let's start at the top. The first thing we need to do is import all our libraries. First, we'll import Express, which is our web server. Then Axios, which we'll use to talk to the ZEGOCLOUD API. Then Crypto for generating secure signatures. .env to load our secret keys from our env file. And finally, we'll import our generate token O for function from the token helper.js file we just created. Great, now, let's initialize .env by calling .env-config. This loads all our secret keys. And we'll set up our Express app. We'll create the app and tell it to use the express.json middleware so it can understand JSON requests. Now we'll define our constants. Our port will be 8080. Then, we'll get our Zego app ID from our .env file and use parse int to make sure it's a number. Then we'll get our Zego server secret. And our Zego API URL. And we'll create a map to keep track of our active agents and a null variable to hold our registered agent ID. Okay, we need to helper functions to talk to ZEGOCLOUD. The first is generate Zego signature. This is a standard function from their guide that creates a secure signature for all our API requests. Inside, we'll get a timestamp. We'll create a nonce using crypto random bytes 8. Then we build our signed string from our app ID, nonce, server secret, and timestamp. Finally, we create the signature using MD5 and return the complete object. Our second helper is make Zego request. This will be an async function. It takes an action and a body. Inside, we'll get our signature. And build our query string. I'm using URL search params here, which is a great, easy way to build a query string. Then we create our final URL. Now, let's log the request so we can see what's happening in our terminal. Now we'll create a try-catch block. Side try, we'll await an Axios post call with our URL, body, and headers. We'll log the response and return the response data. In the catch block, we'll log the error. And then throw the error so our other functions know something went wrong. Okay, now for the most important function on our server, get or register agent. This will define our AS personality. We'll check if we've already registered an agent, and if so, we'll just return the ID. If not, we'll create a new agent ID. And then our agent config object. This is where we define the AI brain. Now, let's go to the ZEGOCLOUD guide. I'll scroll down, and from here, we can copy the LLM and TTS configurations. This is the easiest way to get started. The LLM is the brain of our AI. It's the large language model that thinks of the replies. The TTS is the voice, or text-to-speech, that turns the AI text into audio. You'll see for the API key, we're using Zego test. This is a special key for testing. You have to enable your app ID for this, so just contact ZEGOCLOUD support and they'll enable it for 2 weeks or more for you to test. And this system prompt, this is the most important part. This is where you can write the system prompt to define the AI's personality. You can write anything you want here for your own organization or institute to make the AI respond according to that. Okay, now we have to write the ASR, or speech recognition. For that, let's go back to our guide. On the left panel, I'll click on Configure ASR. If we scroll down, you will see the 4 types of ASR. Tencent and others. For this video, we'll use the Microsoft vendor, but you can also test the other ones. Let's go back to our index file and write this in for our ASR block. A pause interval of 2 seconds to help it capture our full sentences. And the language to English US. Now, we just call make Zego request to register the agent. We'll check the error code. And if it fails, we'll throw an error. Finally, we'll save the ID to our cache variable and return it. Okay, time for our API endpoints. First, app.get API token. We'll get the user ID and room ID from the query. Add a quick check for errors. And then start our try block. Inside, we build the payload object. This is where we set the permissions for the user, 1 for login and 2 for publishing a stream. Both are set to 1, meaning allow. We'll turn that into a string. And then call our generate token 0 for helper with all our info. Like our app ID, user ID, server secret. (3,600 seconds for expiration). And our payload string. Let's log a success message. And return the token to the app. We'll also add our catch block to handle any errors. Next, our main endpoint app.post start call. And our logic check to make sure all three exist. Inside our try block, we'll get our agent ID by calling get or register agent. Then we'll define the agent user ID. And then agent stream ID. We create another token, this time for the agent to join the room. Now for the instance config. This is a big object. Let's go to our blog for this. Scroll down to find it, and here it is. I'll just copy this whole instance config block. Okay, let's select this whole block and press Tab to indent it correctly. Now, we need to add our token at the top. Let's correct those typos so they use our lowercase variables. Okay, now for the remaining code. We call make Zego request with create agent instance and our new config. We check for an error. And if error is successful, we get the instance ID. Save it to our active agents map. And return it to the app. And of course, add our catch block. Almost done. Let's create our app.post stop call function. This one needs to be async as well. Inside, we get our ID. We check if an ID exists. And in our try block, we just call make Zego request with delete agent instance. We check the response code. Then we clean up our active agents map to remove the agent we just deleted. And return success. And we'll add our catch block. Next, the callback endpoint. This is for ZEGOCLOUD to send us server-side events. We won't use it for this tutorial, but we'll set it up to log any messages it receives and send an OK response. And the final line, app.listen. Now, right here, you need to put your own computer's local IP address. To find this, open your command prompt and type ipconfig. Copy that IPv4 address and paste it right here in the string. Alright, I've got my entire index file written out. But if I tried to run this, it would crash. I've made a bunch of small typos, which is a normal part of coding. Let's go through and fix them together, from top to bottom. First error is right at the top. I've misspelled parse int. Next, in our generate Zego signature function, I've typed ransom bytes. That sounds a bit scary. It should be random bytes. Let's fix. Okay, in the make Zego request function, I've misspelled URL search params. And a big one right here. On the next line, I'm trying to build my URL. I've used single quotes instead of backticks. Single quotes don't work with template variables. We need to change both the start and end quotes to backticks. And it should be Zego API. I've made the same mistake in my console log lines. These single quotes should be backticks. Moving down to get or register agent, same mistake again. I'm defining my agent ID string with single quotes. This needs to be backticks. And in my register result check, ZEGOCLOUD AI API always returns error codes with a capital C. I've written lowercase. In my API token endpoint, more single quotes that should be backticks. And a small typo here, that should be JSON. Now for a big, critical logic bug in start call. Look at my if statement. This would let a user with a room ID but no user ID pass. This is wrong. It should check that all three are present. And more single quotes here that should be backticks. I actually just bought a new keyboard, and to be honest, I'm having a hard time differentiating between the single quote and backtick keys on this keyboard. So make sure you are using backticks for these template strings. In stop call, I've misspelled async. And the very last one in my app.listen function. I'm trying to log my server's IP, but I've used single quotes and a plus sign. The syntax is all wrong. Let's fix it by using backticks for the entire string. And that's it. We've hunted down all the bugs. Now, when we save this and run npm start, our server should start up perfectly. Let's try it. Our server setup is running successfully, which is fantastic. Now let's go back to Android. Let's quickly polish up a few last details in our main activity. First, in our login to room function. Also, I almost forgot a crucial step for our server. Open your command prompt in the server folder. You must run npm install express axios.env to download the libraries. If you don't do this, the server will crash immediately, so make sure you run that command. Back in Android Studio, let's fix our app's look. Go to themes.xml. We want to change the parent theme to theme.material3.daynight.noActionBar. You'll see it turns red because we're missing the library. Go to your build.gradle.kts. Scroll to dependencies and add this line. Click sync now. Once that's done, if you go back to themes.xml, the error is gone. Now back to MainActivity.kt for a quick bug hunt. Scroll down to handle permission denial. Let's uncomment the call to show permission denied permanently dialog so our user actually sees the alert. Now scroll all the way to the top. I made a typo here. Next, scroll down to set Zego event handler. In on-room stream update, look at this check. I wrote agent with 2 dots. That's wrong. It needs to be agent with an underscore, or the app won't recognize the AI. And in on-rec experimental API below it, let's just fix the capitalization in this log message so it looks professional. Almost there. Because we are connecting to a local server HTTP, Android will block it by default. We need to allow it. Right-click Race, create a new XML resource file, and call it network_security_config. Paste in this code. Important thing is that you must put your own computer's IP address here. Check your command prompt with ipconfig to find it. Now open Android manifest, XML. Inside the application tag, add this line. This tells the app to use our new rule. And finally, in main activity, we add our last function, fetch token and login. Go to our main activity. This is what connects our app to that server. Inside fetch token and login, the first thing we do is update the UI. We'll find our status text and set it to fetching token, so the user knows something is happening. Next, we define the URL for our server. We'll use the constant server URL we created earlier, and we'll add the API token endpoint. Now we create our OKHTTP client. This is the object that actually performs the network request. Then we build the request itself. We use request.builder, pass in our URL, and call.build. Now we execute the call. Remember, enqueue runs this in the background so our app doesn't freeze. We'll pass in a new callback object. This callback has 2 functions we need to override. First is onResponse. This is called when the server answers us. Inside onResponse, we first get the response body as a string. Then we check 2 things: is the response successful, and is the body not empty? If either of those checks fail, we have a problem. We'll use run on UI thread to show a toast message saying failed to get token. And then return to stop the function. If the checks pass, we're good to go. We'll use a try-catch block to parse the JSON. We extract the token string from the JSON object. Once we have the token, we call our login to room function, passing the token to it. And importantly, we wrap this in run on UI thread because login to room updates the UI. If the JSON parsing fails for some reason, we catch the exception and log an error. The second function to override is onFailure. This happens if the app can't reach the server at all, like if the Wi-Fi is down or the IP is wrong. In here, we'll log the error message to the console so we can debug it. And for the user, we'll show a toast message on the main thread saying cannot connect to server. And that is it, we have written the final function. Our app can now fetch a token, log into ZEGOCLOUD. Now we store the IP address in our constant file, because if our server's IP address ever changes, we only have to update it in one single file. In our constant file, we add a new line for your server's base URL. Now, go to your MainActivity.kt file and update your functions to use this new constant. First in your fetch token and login function. Then in our stop call function. Finally, open your server API file and write in your notify server to start call function. Our code is now much cleaner and easier to maintain. Now let's run our AI agent app, the moment of truth. I've connected my physical phone. Let's hit run. The app launches, permission granted, fetching token, and login successful. Now, let's talk to it.
I'm doing well. Thanks for asking. How about you? Enterprise routers handle larger networks with more complex traffic management and security features, like firewalls.
It works perfectly. The AI responds with both voice and text in real time. One of the best features is that you can interrupt it at any time just like a real conversation and it will stop and listen to you clearly, even if you are in a noisy or rushy area. And the most important thing to remember is that you can change the system prompt on the server side. This allows you to completely customize the AI's personality and knowledge to fit you and your organization's specific needs. And that's it for this tutorial. You've built a full conversational AI assistant. If you found this helpful, please smash that like button, subscribe to iTech Aspirant for more coding and tech tutorials, and drop a comment below if you have any questions. The full code will be available on GitHub. Thanks for watching, and happy coding.